So we got a few minutes before the official time. I thought I'd look at some of these news articles. So they've got these things in the UK and they're expecting them by the end of the year in San Francisco. And it looks like my video is not going to play. They're like this. They're on wheels and they're robots. So they drive around like a little box on wheels and deliver things from one point to another. So this is an alternative to drone, probably a whole lot more practical and safer. So we should see those by the end of the year in San Francisco. Then I'd like to see you log into an app, you pick when something is going to be, and it will find you from your phone, and just this little thing will drive up to you and give you your thing. So it sounds good to me. We'll see. Yeah, good. Now my site's been blocked by a lot of antivirus engines, and they seem to have the sense to notice that I took down the files they were complaining about. So maybe they'll take it off. Those are classroom demonstrations from 4 years ago. It took them 4 years to notice it. Anyway, these guys decided to humiliate Facebook, and they decided to make 50 ads in the name of all 50 US senators without any credentials at all, and Facebook totally fell for it. The only two they busted were like really famous people. So Facebook claims they're like more carefully screening things, and their argument is they're not screening anything. Anyway, I think Facebook's system is not to have any way to identify things, but to respond to complaints. But anyway, it is certainly possible to put up things that are fake on Facebook still. So Google, I think New York Times started this. They found executives at Google that had sexually abused women or accused of it, and they would fire them and give them huge bonuses to get rid of them and then cover it up. And this all came out, and so now a bunch of Google employees walked out today. The BBC, on one report I saw, reported as a few hundred. NPR reported it as 10,000. A bunch of Google people walked out to protest, and they're all quite upset. That's what they reported, yes. So they said more than 10% of their 180,000 employees walked out. Yeah, I think worldwide. It's a worldwide walkout. I heard these numbers. I didn't really know. Anyway, and the Google CEO, Sundar Pichai, said he's all for this. This is ridiculous. We really shouldn't be treating people like this. Nobody should be covering these things up. So it's the right thing to say. So we'll see what happens. This is part of the Me Too movement continuing, I think. And so Tether is a completely fraudulent operation. This is, I don't know if you remember the 2008 financial crisis. You could get a mortgage loan, and then you could sell that loan to a third party. And then they started inventing more and more complicated ways to package these together into financial derivatives so they could lie and tell people they were good investment when they weren't. And it caused a huge meltdown in the whole financial system. And Bitcoin is pretty much all just the same thing. And Tether is the latest complete nonsense. It is a coin that is supposedly worth $1. But they don't really have any dollars to back it up. And they print billions of dollars more of every month without any money to back them up. And so then they pump up the price of Bitcoin with it. So anyway, they now have a new bank account with yet another shady bank because the previous bank decided to quit working with them. However, Ron Paul thinks Bitcoin could prevent recession. If you remember, he wanted us to go back to the gold standard too. He's always been sort of a wild man about money. And he seems to have decided that cryptocurrency is the answer. I have the same attitude of almost every financial professional, which is that Bitcoin is complete garbage. It's nothing but a bunch of small children pretending to be a bank when they aren't a bank, trading something that's worth nothing and tricking people into paying money for their video game. But the fact is, it keeps growing and growing to where there's a lot of money there. So, but this happens in unregulated markets. People throw a lot of money at something that actually has no value. And maybe something in the cryptocurrency space will actually turn to have some value, but so far it's all promise and no product.
Is it just about enough countries and people agree that it is a repository of value? And then
that's correct. That's what they say. They say it makes as much sense as fiat currency ever did, since you don't have the gold standard. The only difference is fiat currency is backed by governments, like the US government. This is backed by nothing. So I think ultimately that's a problem, but they don't think it's a problem, and we're going to see an enormous amount of money flowing into it. Although none of these blockchains have the ability to handle enough transactions to be of any use as they exchange of media. And it's very much like religious zealots. Every time they define what it's for, you prove it's not for that. They say, well, it was for something else. It's not for that. First, they said it was a medium of exchange, but then you prove it absolutely failed as a medium of exchange because the price keeps fluctuating and it cannot handle transactions fast enough to do anything. Then they said it's a store of value, but it wildly fluctuates like mad, so it's not a good store of value. So no one knows exactly what financial purpose these things serve. But everyone's convinced that somehow they're going to revolutionize the world and throw your money in it because it's going up. But that, I think, is just like a pyramid scheme. It goes up for no reason for a while, and then it crashes. Anyway, we'll see. There's some kind of charity event where you have a brief period of time and you perform hacking challenges, but these challenges have already been solved. I'm looking at them. I know quite a few of these. So I'm not quite sure I know the point of this, but it's some kind of fundraiser for some charitable activity, and I guess it'll involve watching people solve these. Anyway. Some people are looking for people to do that. I don't quite understand it yet. This, I was quite surprised, and I'll be putting this in some of my classes, probably the 127 class on Saturday mostly. Address-based layout randomization, which is a defense against buffer overflows, does not randomize all the code. I was surprised. It doesn't move the text section, which is where the code is. It only moves the stack and perhaps the heap. And this apparently is by design in Linux. I observed it's still true in Windows Server 2016, so it is very curious. Anyway, so Coinbase is the best cryptocurrency exchange. As far as I can tell, they are the most honest. They're trying real hard to be legal. They have the respect of serious banks and of law enforcement, as far as I can tell. So in this business, which is 99% crooks, they are the one honest entity. And they have an $8 billion valuation. They just had their Series E funding, and they're not going public yet.
Is Wall Street? Is Wall Street funding?
No, I don't know who funds it.
Oh.
Angel investors, probably. I mean, the kind of people invest in startups.
Well, how's it different, Sam?
It is different because they are public, they're very open about what they do, and they're very determined to be legal. So when the government comes to them with financial regulations and tries to enforce that they have good policies like banks, they comply. For example, government FBI came to them about 9 months ago and said that the total amount of Americans that have ever paid any income tax on their Bitcoin is 800. And therefore, they have concluded that owning Bitcoin is prima facie evidence of tax evasion, and therefore they demand their entire customer list so they can prosecute them all for tax evasion. And they resisted and went to and made a deal, and they agreed to give them everybody with more than like $20,000 in Bitcoin, and they gave it to them. And I thought that would be the end of them because I thought everybody would use them to hide their taxes, but apparently not. So I mean, they are trying to meet government demands and obey all the rules and have enough lawyers and forms and everything to really meet the requirements of being a bank or whatever it is they have to be to trade Bitcoins, which is very unclear, of course. Nobody really knows what the rules are, and they keep changing. So it's quite difficult to meet the requirements, but they're doing it. Yeah.
So we may have the opportunity. Somebody sent me an invite to tour Coinbase.
Yeah, I'd like to do it. I'd like to have them come here. I mean, they're very, very welcome. They're the best in this space. There's a ton of money in it. Well, but I think cryptocurrencies are garbage, but Coinbase is the best of a bad lot, and I'd be glad to have them here. So I mean, I've invited them a few times, but I think they're too busy handling vast piles of money to come here. But if we have a chance to do anything with them, I'd like it.
I'll see if this event is still available. I'm not sure.
Yeah, sure. Let me know because almost all the rest of them you wouldn't want to have anything to do with, but Coinbase is the exception. Okay. They are not going to besmirch our college reputation that we're partnering with them, I think. No, that's right. Now, Splunk. So Splunk is the #1 security intelligence event monitoring system. I've got projects in other classes doing it, and I think it's about time we just had a Splunk certification class. So I want to get the certification myself. It'll cost $5,000 to take their class, so I'm looking into this. Maybe over the next year I can get certified, and then we can just start teaching Splunk certification. I think it's about time for that. It is the leader. It is super important. And so I'm going to go get the certification, and then I'll be qualified to decide what level we should teach it here. Yeah.
Do you think there are products that we potentially see competition from all the other products that you sort of?
Well, of course, there's competition from other products, but these are universally recognized as the market leader. So I think, in the same sense as we teach Cisco or Microsoft, they're not the only ones, but they're the giants in their field. And I think Splunk is a giant like that. So it's worth learning it. And also all the others are very similar. So even if you used something else, your Splunk training would not be going to waste, I think. But I'll look into it more, but it looks to me like it's a doable thing, and we could turn it into a class or two here, and we really should. So Morgan Stanley is now trying to define a cryptocurrency asset class. I mean, you can certainly invest in this stuff and make money if they could somehow make a less risky derivative. By the way, you can close that curtain if the light bother you getting in your eyes. Okay, anyway, so they're trying to make a financial derivative of some kind, including Bitcoin and currencies that they'll sell on the stock market. They've been trying this for about the last year. Remember, these are the same people that sold the financial derivatives that crashed the entire market 10 years ago. These guys are certainly not in a less criminal category. I mean, these are this, but they're too big to fail. So even though they completely lied and betrayed everybody, nobody was punished, and they were just given a handout to bail them out. And now the regulations have been relaxed again, so they can do it again, as far as I can tell. And this time it'll be cryptocurrency. And anyway, so that's where we're headed, for better or worse. I would think worse, but I'm all old and conservative and boring, and I think money should be backed by governments, and people should have laws and all these boring right-wing things like that. Anyway, well, that's I don't know if it's correct or not. We're going to find out. Yeah. There is a way to short cryptocurrency. You totally can. There are funds just for that purpose, and you can try it, but I don't trust it to go down either. I just think there has always been this is what a high-risk investment is. It's something that goes up and down a lot. That's all it means. Risk is equal to standard deviation, variation over mean. And cryptocurrency has a very high variation. So there are moments you could buy it when you could get rich, but this is high-risk investment is for people that like to dig for gold. If you actually want to get rich, by far the best thing you can do is get a job and just get a regular paycheck. You will end up far better off than any of these idiots doing things to get rich quick. If you just get a normal job, you'll have a lot more money almost all the time. Anyway, that's the old-fashioned boring stuff that I recommend. Anyway, all right, I think we're close enough to the real time. So today we're going to talk about hacking web servers, but before we do that, I want to say some words about some projects, because I added some projects that are pretty unusual to this class and deserve some explanation. So to get down here, for example, the quantum computing and the blockchains. Let me talk about these. I don't know if it's worth demonstrating them entirely, but it's worth talking about them. So quantum computing is really important. In normal computers, digital computers, you use only the states 0 and 1. And then you flip bits from 0 to 1, and you do XOR and left shift and all that jazz. And this is transistors. And this is the way everything has been done for a long time, since before electronic computers. Quantum computers use this property of the real world. The real world does not work that way. The real world works this way. Individual particles are not in the states of 0 or 1. They are in uncertain states halfway between 0 and 1. That is the way they really are, and they don't collapse into a certain state of 0 or 1 until they are observed. This is madness, but if you study quantum mechanics, you can get used to it. Plato wrote about this. He said, if you lived in a cave and all you could see were the shadows on the wall, you would have a very strange idea of the world. You would think the world was only 2 dimensions, and when things get in front of other things, they just vanish. And that is exactly what's happening. We live in a world of quantum particles that are uncertain, and we only have limited experiences that lead us to imagine that the world is certain, and objects are in a place, and when they move, they're in another place. All that is only a limited, weak approximation of the truth. So if you use quantum computers, you can use fundamental particles for their full value. There's a video I saw of North Korean prisoners where they have about 1,000 prisoners all dancing in unison. And this is what you take a human that could be doing anything, and you make 1 million of them move together, and you encode a 0 and a 1. And that's what we're doing with our electrons in modern computers. The electrons are very powerful quantum objects, and we gang them together by 1 million and move them in one state and call it 0, and another state and call it 1. So we're only getting a tiny fraction of the actual computing value of that electron. You could get a lot more value out of it by using it the way it really is and letting it behave naturally. And that's what quantum computers do. They exploit the real motion of fundamental particles for its full computing value. And it turns out they can solve a lot of problems much faster in principle. The problem is, it is very difficult to build hardware that can manipulate these things accurately. And currently it's ridiculously expensive. What's that? Yes. Right now, there's 2 problems. The first one is coherence, and the next one is noise. They have to, so right now, the only way to do this is to make magnets and cool them down to about 1,000th of a degree above absolute 0. And then they actually hold the state long enough for you to work with them, but they still have too much noise. So the current quantum computers are just proofs of concept, but they need to get significantly better than they are now before they will achieve quantum supremacy, which is when we can actually do anything real faster on a quantum computer than a classical computer. But you can use real quantum computers now because IBM has gotten involved and they give you a free one you can use online. So you're connecting to their server and they have a quantum computer that has 5 qubits and you can program it by just putting actions on a musical staff here. There are fundamental actions you can do for the quantum computer, and here they are. So if you measure, which is this one, looks like an umbrella, that's a measurement, which will take this qubit and measure it. Now this qubit starts in a state of 0. So when you measure it, you get a 0. There are 5 qubits. So when you measure it, you always observe a 0 or 1. But if you now put in an X, which rotates it to an uncertain state, half 0 and half 1, and then measure it, now you'll get, oh, see, that rotates it all the way to 1. Here's the one that rotates it halfway. There, quantum uncertainty. There. This is the H is the one that rotates it to a state where it's half 0 and half 1. These ones are both 0. So when you measure it, you have 50% chance of a 1 and a 50% chance of a 0. And it's not exactly 50 because they literally do it 100 times and show you how many. It's not enough to average it out to a high degree of precision. But the point is, this is what's an uncertain state is. These are all the same state, but when you observe it, it collapses one way or the other. That's the way the real world really is and the way quantum mechanics is. So you can now make superposition states. If you make 3 uncertain qubits that are independent and measure them, then it's just like flipping 3 coins. There are 8 possibilities, all equally likely, from 111 to 000. But if you entangle them, which is going to be down here, there's an entanglement. You can entangle 2 things together, and now this one is uncertain, this one was in a state of 0, but by entangling it, it's linked to this one, so these 2 have to move together. So now, even though this one was 0, it was entangled with this one, which is flipped to 1, and that makes it turn to 1. And you can entangle uncertain states, so even though there's only one uncertain bit here, one uncertain qubit, these 2 qubits will move together. So they move from 0, 0 to 1, 1. So that's the magic. And this entanglement is a strange quantum mechanical connection between qubits, which cannot be done with bits. And that is largely why they can do special calculations that you cannot do with digital computers. They have a different fundamental physics connecting them together, and that makes the way they relate different. And therefore, different problems become easier. And in particular, factoring compound numbers into their primes becomes much easier, and that's what matters most to us directly. This is going to destroy RSA. When quantum computers actually work properly, you'll be able to factor compound numbers into their component primes very quickly, and that will break all the RSA encryption. So we're currently developing quantum-proof encryption that does not rely on something that would be broken by a quantum computer. And I'm planning to write up for my 141 next semester. You'll be playing with that, the New Hope, which is Google's. There are 51 surviving candidates, 58, something like that, in the contest at the NSA, at the NIST, to determine what will be the standard algorithm for post-quantum cryptography. And the current main contender is Google's one called the New Hope, which is a version of lattice cryptography. Yeah?
I was going to ask about that. Isn't elliptic curve supposed to be?
Elliptic curves will not survive either. Elliptic curves are an alternative to RSA, and they rely upon a different, difficult one-way function, but that is also expected to be destroyed by quantum computers. So they need a whole new class of public key algorithms that do not get faster on a quantum computer. And there were 88 submissions or something, and a bunch of them have already been hacked and broken and removed, but there's still some survivors. This is what they usually do. They have a contest. They invite everyone to submit algorithms, and then for like 5 years, they all attack each other's algorithms, and then they choose the winners and give it the stamp of approval and call it like advanced encryption system, the recommended encryption system. And all the government-oriented bodies switch to that one, and all the rebels choose the runners-up, which are really just as good, but they didn't get the stamp of approval from the government because cynical people, unfortunately, correctly believe that the government usually puts a secret backdoor in the one they approve, which they have been caught doing absolutely 3 times and suspected a few more times. So the other people that don't want to do business directly with the government would prefer to use a runner-up that has not been altered by the government. Anyway, so, all right, and then there's blockchains. This one here is the simplest blockchain project where you just get to use a simulated blockchain. And the point of this thing is you can put data in and it will show you, I should be able to get this one here. This is what Bitcoin and Ethereum and all those things use. So here's a blockchain. If you put data in here, Sam has 10 coins. It turns red because the blocks have not been mined. So there's a hash value of all this data, which goes down here. And when you mine it, it changes this nonce until the hash value starts with a certain number of zeros. Here it looks like it's 5 zeros. So now this block is considered mined, and the hash of this block is added to the next block. So now, if Bill mines this one, he gets 10 coins, and then mines it, because there's a reward for mining blocks. This is how Bitcoin works. And now this one is mined. And if somebody tries to lie, like this guy tries to get more coins, then all the blocks are invalid. This one's invalid because the hash doesn't match, and this one's invalid because it contains the hash of the previous one, and that's the point of the chain. You could verify the latest block, and if it works, that proves that all the rest have not been modified. That's why the idea is you can have a financial ledger, a record of everything that's happened that cannot be altered, that is too expensive for anybody to alter, but it's easy for anybody to verify. That's the point of it. And again, it relies on these one-way functions. And Bitcoin uses SHA-256 of SHA-256, which in retrospect was a pretty unwise decision because it led to centralization of all the mining in the world in China. Because the only thing that matters to make you the fastest is pure CPU speed. And it turns out the only thing that determines that is the price of electricity. And only in China is it easy to bribe somebody to get free electricity in large quantities. So that's where all the Bitcoin mining is happening. But the government of China might drive it out of there because they really don't like this much. They have the sort of old-fashioned thinking that I would have, and they say, what exactly is the value of all this Bitcoin? Why are we spending all this power making this stuff? I don't care that somebody is paying you money for it. What exactly is the accomplishment here? Which is mighty hard to answer. That's what bothers me too. You know, there isn't any corn, there isn't any shoes. What exactly is the point of all this? And that bothers the Chinese government, so they're not exactly encouraging it. In fact, they're thinking of like outlawing it and driving it out, even though some people are making money. Doesn't really seem like it's improving your society to have this activity going on. But anyway, yeah. Yeah.
All the values change. They just revert to the last founded state, or they.
Well, the point of Bitcoin mining is you have a lot of miners all over the place. I'm just going to close this. You have a lot of people mining, and you have a pool of miners. And when you mine a block, you don't get paid right away. You only get paid when you announce on the block to the network that I mined it, and the other miners agree that you mined it. And there's a vote. And when they all vote and say, yes, that's really the answer, that block is accepted as mined, and they all start mining the next one, and then you get your money. So it's basically democracy. All the miners get to vote. And that's why there's a very simple attack. If you actually owned 51% of the miners, if you formed a conspiracy, you could totally lie about the blockchain. You could forge it, and you could refuse to let the other people's mined blocks be accepted and force them to accept yours. And you could mine one and not tell anybody and wait until it's time for the next one, and then they'd be wasting their time mining one that's not going to work. You could totally freeze everybody out and steal all the money. That's the 51% attack. And this is close to the Byzantine generals problem, is the general computational problem here. What if you have a bunch of generals that have lied to invade somebody, but they don't really like each other, and they would like to turn on each other? Then what do you do if some of them are traitors? And the mathematical solution says the best you can possibly do is have a system so that a whole 1/3 of them would have to band together to cheat to win. That's the best you can accomplish. But in the simplest case, you'd think it would take 51% of them to wipe out the others, to turn on the others. And that's where, so if you actually could own 51% of all the processing power, the whole blockchain concept would be shot. And but Bitcoin is quite successful at making it so you have a financial incentive to play the game fair. You'll make more money by just mining blocks than you will by somehow tricking everybody. So as far as anybody had known, there's never been a successful 51% attack on Bitcoin. But there have been on the smaller cryptocurrencies, because the smaller ones are less popular, and there are not as many powerful computers in the mining pool, so you could, in fact, reasonably get enough power to make a 51% attack, and it's happened 6 times that we know of. Yeah.
You may have touched on this before I got here. Yeah. What exactly is the content of each block?
Just this. How many coins people have. That's all it is. So everybody that mines gets an award. Here I'm presenting as 10 coins. And if somebody trades coins, that's in the block too. Just like your bank. You have this much money came in, this much money went out. That's all it is. And that's why it's amazing that the most popular activity on Bitcoin is crime, because every single transaction is in a public chain for everyone to see, including the cops. So it's kind of strange to imagine that you're going to commit a crime and get away with it here. Of course, all there is account numbers. And if you really know what you're doing, you create a large number of random account numbers and keep using a different account all the time. So it's hard to track your money. But in fact, the cops are getting pretty good at that, just like they're getting pretty good at tracking stuff through Tor. These problems are not impossible, they're just difficult. And that's why there are other coins like Zcash and Monero that have another layer of randomness to try to conceal things, and they call themselves privacy coins. And they're out there, but Bitcoin is the only one that really got big. Yeah.
What actually determines
The design of the system determines the amount of coins. Bitcoin was designed by a guy that used the fake name Satoshi Nakamoto, and as soon as it started, he vanished and never came up again, even though he has a huge amount of money in Bitcoins. Not even to collect his money. He said, I'm going to have nothing more to do with it, and left, which is not exactly reassuring. But anyway, he designed it. There were a bunch of people trying to invent digital cash. It's been going on for like 20 or 30 years. What would be the right way to move money on the internet? There are a bunch of previous attempts that totally failed. This is the one that was considered the best, and he designed it with the idea that you could save money in it like gold. So it would retain its value. So he didn't want it to be inflationary. So what he did was, Bitcoin started with mining. You'll mine one block every 10 minutes. Every time you mine a block, you get an award of 50 Bitcoins. And that's all the Bitcoins are created. And he mined them alone for a while, and his buddies mined them when they were worth nothing, until there was, the first couple of years worth of Bitcoins, which is 50 coins times every 10 minutes for a whole couple of years. So I don't know what that is. Million Bitcoins or something was out there. And then every 4 years, the award is cut in half. So it fell to 25 coins per block, and then to 12.5 coins per block. And that means the total number of Bitcoins there will ever be is 21 million. They are created by miners. And after a while, the mining reward becomes small and negligible. So the only thing that makes you mine is the transaction fees. And the transaction fee is a tip you put in your transaction. So if I want to give you a Bitcoin, what I do is I make a transaction that gives you a Bitcoin and that subtracts 1.1 Bitcoins from my account and gives you one. There's 1.1 left over for the miner as a tip. And the miners see these transactions floating over the network, and they don't have to mine all the transactions. The miners can sweep up the transactions and make a block and mine it, and they could leave your transaction out of the block. So if you don't tip them enough, they will not mine your transaction, and it will not happen. So the idea is there'll be a free market in how much the transaction fee should be. And as the mining reward goes down, the transaction fee will come up to whatever level is necessary to motivate people to keep mining. And if everybody quits paying tips, then the miners won't mine anymore and the thing will stop. But that's not what happened. Anyway, that's the plan. It was designed thinking of all this, how it would last forever. And after a while, maybe 20 or 30 years, there'd be no more new Bitcoins. You'd just be trading the old ones back and forth. The problem is there's so much crime and technical problems. 7% of all the Bitcoins in the world have been destroyed. And Satoshi Nakamoto owns a ton of them, and they seem to be gone. People think he's dead. Who knows what happened to this guy? He had a ton of Bitcoins, and they're just sitting there forever. No one's taking them, and many people have tried to find him because he's worth an enormous amount of money. If he sold those coins, it's incredible. That giant pile of money is not enough to make him come out of hiding, but it isn't. He either doesn't care at all or he's dead or something. But anyway.
How much would that be? I know Bitcoin went up to like 23,000.
Oh, yeah, let's get the Bitcoin market cap. I think he owns like 10% of all the Bitcoins. Let's get the Bitcoin market cap. It's huge. It's like astronomical money.
It's pretty volatile right now, but there was that one point where it was.
There's the market cap, $110 billion, right? Yeah, $110 billion. So he has billions of dollars of Bitcoins, and he's not taking them. They've been sitting there for 10 years now. Because he mined in the early days when there was nobody cared. It wasn't worth anything. He ran the first couple of years of mining pretty much alone. So he had piles of Bitcoins. And he just said, the last post, he said, well, okay, I think I'm done with this. I'm going to go do something else. You guys have fun. And never came back. What's that?
How much is Jeff Bezos?
Bezos, yeah. Bezos, I don't know. A lot.
It's like, is it like,
anyway, there's a lot of money. That's $100 billion is Bitcoins.
There being any negative effects if he did?
Oh, if he tried to sell them all at once, of course, the price would fall. But he could dribble them out. And even then, there'd still be a lot of money. That's why a lot of people are afraid. That's one of the things some people worry about, is that he might reappear and sell all that and make the price fall. But the price goes up and down so much anyway.
And a lot of people would probably see that and start buying Bitcoin.
It could be. Anyway, so a lot of people are speculating in it. But anyway, so this is a blockchain. That's what I wanted you to see there. So you get some idea how blockchains work. And then there's Hyperledger. Now, that Bitcoin is a public blockchain. The purpose of it was to disrupt the world financial system. The reason it exists is because this guy was very upset about the 2008 financial crisis I was talking about before. And when they bailed out the British banks And the American banks, they called it TARP over here, they call it something else over there. In both cases, they just printed an incredible amount of fiat money based on nothing and gave it to the banks to bail them out because they had defrauded their customers to steal the money. And they propped them up. Well, many people were very upset about that, including me. That also violates my old-fashioned concept of how finance is supposed to work. You're not just supposed to bail out crooks that lose in the marketplace with money that's not worth anything. That's supposed to be a disaster. So that's why he made Bitcoin. He said, this is horrible. We can't have this garbage. We should have a new currency that no government can mess with. So no government can print more. No government can devalue it. That's it. We're going to have something like gold that's outside all the governments. That was the point of Bitcoin. And for better or worse, that's what it is. No government controls it. Nobody can stop it. Nobody can freeze it. It's just a bunch of computer nerds around the world. Unless you shut down the whole internet, Bitcoin will continue whether you like it or not. And if you want to change the price of Bitcoin, you can't. Nobody can. People trade whatever they want for it. So he's right about that. That was his point. So that is, it is basically a political stunt to change the world financial system. But that is not what most companies want to do. Most companies would rather participate in the existing industrial system and make money the normal way. So then they have blockchains. They don't want to change the world. They just want to store their data more efficiently. And that's what Hyperledger is for. Most people, the Bitcoin is this public blockchain where everybody in the world can mine. And that means it's got to have this system where even the fastest computer in the world couldn't cheat. But most people don't have that problem. They just have a small group. Like I'm a bank, and I have another bank, and I have like a supplier in another country. And I have people I'm doing business with that might lie to me and fail to produce, and I can't really sue them or anything because it goes across international boundaries. So I wish I had some way to punish them and control them and restrict what they do, even though there isn't really a court overseeing us. That's the idea. I want to deal with people I don't trust, but I don't want to get the whole world. So Hyperledger is intended for this. This is IBM's blockchain solution. And this is what I think everyone should be learning. That's why I put it in here. I think Bitcoin is pretty much nonsense and you should just stay away from it. I think it's of no importance. It's going to pretty much fade out. But this you need to know in the world of computing, because this is going to be part of every computer network very soon. Right now, everybody has an email server and a web server, and they got a domain controller, and they got a database server. And some of them even have NoSQL databases like Cassandra. That's a common thing, or Mongo or something. There are different kinds of databases for different purposes. And all blockchain is another kind of database. And it is for a strange situation. Most of the time, you don't want this, but sometimes you do. Suppose you got a problem. You got a file on one computer and you want to share it with another computer. Well, you could email it. You can have an FTP server. You could have Dropbox, where you have a folder on this machine and it automatically synchronizes over here. That's fine. You could have BitTorrent, where people store pieces of a file everywhere and you can get all the pieces, and each piece comes with a hash so you can make sure it's intact. But the one thing none of those things do is let many people write into the same file. Now, that is kind of a weird situation. But suppose there's a case where you want to do that, and this is the one: financial ledgers. Suppose I have a bank account and I have many partners. Suppose I have this. One of my students in one of my summer courses is making this for one of the big military suppliers. I forget the name, but one of the big military suppliers is building a blockchain solution for the components that use to supply chain management. This is a use case. So suppose I'm building airplanes. I think it was McDonnell Douglas. I'm building airplanes. I need to have aluminum from here and electronics from there and computer parts from there and fuel from there. And they're all in different countries and they're all somewhat unreliable and lie to me and cheat me. I want to have a record. Here's the promise: you will deliver this aluminum on this date or you will pay this penalty. And you agree to that. Here's where you agree to it. Then here's when you really shipped it. Here's when it really arrived. I want a record of all this stuff happening that nobody can compute. Nobody can lie about it. I want a clear record of what was promised, what was delivered, what you agreed to. Did you pay the fine? That's what it's like. I just want a log of everything that happened. So I want everybody to be able to write to it, but nobody can ever erase or alter anything. It's the same thing to be true of an event log on a server. I want a log of everything that happened, and I want multiple copies of it everywhere so nobody can erase it, and I want it to never get changed, so there can never be any argument about what happened. And that's the case when you need a blockchain. And it turns out that there are a considerable number of cases where that matters, and soon everybody's going to have a blockchain in their company to solve this kind of problem. It's not going to be the main place you store bank accounts or anything. It's going to be used for certain cases, and not public where everybody can mine it, but within your company and your business partners. If you're a bank, your partners and subsidiaries and suppliers will all share a little chain to record things you all have to know, and that'll be it. And you'll probably have a bunch of these different chains for different groups of people involved in different projects. And you won't let everybody mine. They'll be mined by like just your trusted bank server. And so that's what Hyperledger does. It is the business blockchain, and IBM has been pushing that hard and developing it, and developed all these subsidiary products to hold it up. It is as complicated as domain controllers and cross-forest trusts and everything else. They have thought of all these different business situations where you need more and more products for the blockchain. So they made a cute place to learn it called Hyperledger Composer. You can go to Hyperledger Composer blockchain, and you can make a blockchain right in your browser. And that's what this point of this project is. So you can create a blockchain. This is the simplest blockchain you have to think of. This is just a ticker tape to keep track of the price of a stock. It's not even keeping track of how much you own. It's just recording the price. Simplest situation. So you define a network. It's going to have participants, assets, transactions, and events. This is about the simplest thing they could think of. So this, you make this file, and this, everybody in computing always has to write a new language for every single thing they do. I don't know why this is. If they asked me, I would have said not to do it, but everybody has to have their language. So there's a language for this. They all look just like JavaScript too. Anyway, so this is the language, and whatever language they call this, it's Solidity for Ethereum. I don't know what they call this. So here's the definition of a business network. I define an asset and a participant and a transaction. And so now I can make the script file for a transaction. A transaction, the only possible transaction in this network is changing the price of something. That's all. So you have asset old value and asset new value. That's all you have here. Then you can define access control lists. You do have to know who's allowed to do what. So here, everybody can read everything. Everybody can submit transactions. Owners have full access to their assets and a few other things. So this is your limit of the roles of people and what they can do. And now you can have some participants. So I make a participant called Bill Gates, and I make another participant called Steve Jobs. These are the entries, the people in my list. There are two people, Bill Gates and Steve Jobs. Then I create an asset. To create an asset, you just specify the name of the asset, its value, and its owner. And the owner is referred to by their code BG for Bill Gates. So Bill Gates owns this thing called Microsoft, and its value is 100. And now you've created a new asset called MSFT. And now you can perform a transaction. The only possible transaction is to change the price of an asset. That's all there is in this thing. So I set the new value to 105, and that's the transaction. And that's it. And then you can view the blockchain. This is the whole blockchain. What happened is when you created the blockchain, there were 4 blocks created within a few seconds, which created the chain itself. Those are done automatically when you make the chain. Those are things that created the administrative user and created an identity and started the network and activated the identity, and that's also on the chain. The actions that create the chain are blocks on the chain. Everything that happens is always on the chain. All it ever does is grow, and anybody can look back to see everything that happened. That's the point of it. It's a log. And so then things happened that took longer. This all happened within 1 second because it was done automatically by software, and then it took me time to do each of the other things. This is me adding one participant and another. Here's adding an asset, and there's a transaction. And you can view each of those records. You can see a raw blockchain. And so if you click on one, this is what a historian record looks like. Records are just what happens. This is adding a participant. This is when I created Bill Gates. And then, so it has what I typed in, and then it has a timestamp and a transaction ID. So you can refer to that transaction did this. That's the way it always is. The way Bitcoin works and everything. There's a unique ID for every transaction, so you can talk about it. In this transaction, they did that. In this, because the whole point is, you're thinking there will be some argument later, like fraud. Somebody stole the money. You'll say, well, what exactly happened to the money? This person put it here, this person put it there. I used to do financial databases, and that was the whole point. You never erased anything. You always had a record of everything that happened. If you removed anything, you didn't erase it. You put a mark in it, deleted, and then you said, here, it's deleted for this reason. So you could always go back and say, what exactly happened? Nothing is ever removed. That's the point of it. So that's an example of a blockchain. Of course, it gets much more complicated. And then you have you also have events which send information about the blockchain to another application, because it might be important. You might have a price tracker, and then you want to send off to another application that would do something like, for example, warn you that your stock price and your investment is falling and you better sell. That's the kind of thing. So this blockchain has events, and that's what the events are, alerts to send to other applications. So that's all. I thought you should have some practice with that. And the last one in blockchain that I wanted to talk about is the one that makes it most directly obvious, I hope, why it matters for this class. These things are fantastically insecure. They get hacked right and left. An incredible amount of money gets stolen. Now, most of it is through good old-fashioned social engineering. Like you open a Bitcoin exchange, you say, I'll change your, oh, you can buy Bitcoin here. Send me your money. I'll give you the Bitcoin. You pay me a lot of money. I put it in your account. I say it's in your account. Then I just turn off the computer, leave. You come back tomorrow, the web page is gone. Bye. I just took everything and left. This is the main way they do it. This happened over and over and over and over, that people just stole it all. Sometimes even left a message behind, you know, I took the money and left, suckers. You know, sometimes they pretend somebody hacked them, like Mt. Gox that had 7% of all the Bitcoin in the world. He pretended that somebody hacked him. He's in prison, I think, in Japan. I'm not sure he succeeded in convincing him that someone hacked him. It goes on and on. However, that's the simplest way and very effective, is to just trick people. However, you can also steal money technically, and that's what I put down here. This is the delightful people at 4chan. If you don't know 4chan, you probably don't want to go there, but 4chan is a place where the most troublesome people on the internet hang out. And they do stunts and pranks, usually involving very blasphemous, rude things. And they decided to make a Ponzi scheme. Now, a Ponzi scheme is named after the original flim-flam man that created these things around the early 1800s or 1900s, where he takes investors and he takes the next batch of investors and uses it to pay the first one. So as long as it's growing, everybody makes a lot of profit. When it stops growing, they all go broke. It was the early thing that later led to a pyramid scheme. So they said, now they're totally illegal. And they said, let's make something that's explicitly a Ponzi scheme, just for fun. So they made it on the Ethereum blockchain. They said nobody would actually put money in this thing. And of course they did. People flooded in and they put $1 million in the Ponzi scheme, and then it all got stolen because there was a bug in their Ponzi scheme. So you can do it live. There's this fantastic thing called Remix. See, at the end of last year, Bitcoin and Ethereum went way up to an insane price, $20,000 for Bitcoin. So there was so much money flying into the sky that people developed all these tools to help you develop blockchain contracts. Then it collapsed. So I don't think there's money for it now. But in a brief period of time, they created all these training tools that are really nice. So you can run a blockchain right in your browser without anything. It simulates it. So you go to this website and you can make a blockchain. And because everything is open source, not only is the entire source code of this proof of work coin, POWH coin, available, but the blockchain recording the exact hack is available. Like I said, it's a terrible place to commit crime. You can see exactly what the criminal did to steal the money. So you can totally reproduce it. So it's very nice for educational purposes. Although I say, so you go to this GitHub account, you can copy the entire code. There's only 306 lines of code in this entire financial product. So you can copy it here. And by the way, it's written in this language called Solidity, because everybody has to make a new language for every damn thing they do. And this, again, looks just like JavaScript, like they all do. But anyway, so now you copy that into here, and you deploy the contract, and now you have a deploy button here. You can execute, you have a little GUI over here where you can execute things with the button. This is the code that does it, and there's the GUI that runs it. So when you deploy it, it will send the tokens on the blockchain, and now you have a bunch of more buttons. You can do things like fund, to invest in this. This is, like they all are, a crowdfunding scheme. You can invest money, and the money can be handed out to other people, and you earn interest, supposedly, and all that. So you can invest money. The fake blockchain you use here, if you use the JavaScript simulated blockchain, has 10 accounts and they each have 100 Ether. So you can play with it. It simulates the Ethereum blockchain. So you take the first account and you invest 50 Ether in the fund. So you put 50 here and you click fund, and it puts that money in there, and this person's account falls down to 49.999, because every time you do anything on the Ethereum blockchain, you have to pay a transaction fee called gas, which is a tiny little fraction of Ether. So way down here in the far right decimal points, a little bit more money was used than what you actually sent. And so that you add another investor, and they put in some investment, and now you're ready to approve a withdrawal. Now, the way you approve a withdrawal in this system is you approve a withdrawal by account number 3, and then you perform a withdrawal into account number 3. This is how you'd move money into this account number 3. But what happens is there is a flaw in their coding, which you'll see, but the effect of it is pretty amazing. What you do, you choose a transaction. So you go to account number 3 and check their balance, and it's 0 because they have not invested any money in the fund. Account number 1 put in 50, account number 2 put in 1, and account number 3 didn't put anything in the fund. They have 0. What I'm going to do is someone that's already in the fund is going to put money in account number 3. But what you do in the hack is you go to a place, what you do is change the parameters so you're putting money into the fund, but you use the function intended to move data from one customer to another. Now, what they could have done, which would have been more secure, is if you try to use the function to move data from one customer to another, to put money directly in the fund, they give you an error message and say, oh no, go use the fund button. But they didn't. They just call the fund button for you. The problem is the fund button is a transaction that only has one account putting money in the fund. Moving money from one account to another has 3 accounts for parameters. There's the account that's sending, the account that's receiving, and the account that's paying for the gas. And those 3 are all different. And when you move to the account, the function that does fund, it only understands one account, and the account that gets there is the account that paid for the gas. So the end result is you are able to do a transaction which appears to be moving from 2 to 3, but actually ends up drawing one from account number 3 that has a balance of 0. And the if statement to make sure you don't suck out money from the account number 0 actually looked at account number 2 to make sure it had the money. And the account that it actually came from was account number 3. That's the kind of bug you get. So the end result is you get to subtract 1 from account number 3, and it has an integer underflow and turns into the largest possible number. So it has this unthinkably huge number of money after that. Because that's what happens when you have a 256-bit integer that's 0 and you subtract 1, it turns into 2 to the 256 minus 1 or whatever this is. So that's, of course, all the money in the chain, and you cash out and leave. And that's what he did. So, and you can see the exact code. Here's the code that did it. Here's the function that moves from to 2 and goes like this. And here's the function that transfers tokens. And here's the sell function that subtracts from an account. And the problem is this only assumes one account number, and it ends up using the wrong account number subtracted from in this case, which is a pretty simple bug. But these Ethereum smart contracts are all full of bugs like this, and they get hacked all the time, in addition to everything else being a mess. They also get hacked right and left. Anyway, so I wanted to talk about that, and I think we'll also talk about SQL injection, but I'll do that a little later when we get to it in the slides. So, yeah, let me start a little bit with the slides, and then I'll quit when we hit 7 to give you a break, because we're going on a little long today. But it's important, I think, to talk about why I have these goofy projects in here. So, hacking web servers. We're going to talk about how web applications work and how to attack them. So web applications work like this. You have somebody down here with a browser or a smartphone or something running a web client, and they're sending requests up to the server, which used to be HTTP, and now they're mostly HTTPS, so they're encrypted, but it works about the same. And the web server up there is usually IIS if you're a Microsoft shop, like a big company. If you're a smaller company, it's Apache. And there are many web servers out there, but Apache was #1 for a long time, the blue line. Microsoft started eating their lunch. In the last few years, Microsoft became more popular because their web server got better, and more companies switched to using Microsoft products. I mean, what's amazing to me is both in politics and business, the worst thing goes to the top. Microsoft is now the second most largest company in the world. Record profits, they just beat Amazon in total value, and I think their product is worse than it's ever been, but I'm apparently alone here. So that's what, anyway, Microsoft is growing and growing. Many, many businesses use them. And there are other competitors, but those are the big ones, Apache and Microsoft. So these applications on the server have bugs, of course. And the problem is if you have a bug in a web application, millions of people are using it. So it's a bigger problem than just something in a small local application. So if you have a static web page, it just sits there, doesn't do much, and there's not that much that can go wrong. But typically, you aren't content with a static web page just sits there. You want to have things like a buy button and a chat room and a wall for people to put comments on and all that jazz. And in order to do that, you put a form element on the page so you can fill in stuff and hit submit, and then it will send the data up to the server. So here's a simple form I had on my website for comments about my class. And you'd send it up to the server, and it would then pick it up. At this time, I used Perl, which is a really old-fashioned way to do it. I probably wrote this 10 years ago. So it takes the data and puts it up there. Now, after a while, I got this thing full of Italian Viagra spam links. So I put up the horse, where you have to say the word horse, and it didn't even ever change. It was always just horse, but the bots didn't find it for a couple of years. And so you can put in, I put in an anti-spam measure. Nowadays, I'd have to put up the Google CAPTCHA or something to do a better job of that. But that's the game. A script on the server takes that data and does something with it, typically putting something in a database or something like that. And they call that CGA, Common Gateway Interface. And this can be used with any variety of server languages to take that data going up there. C, Perl, Fortran even. I don't know if anybody's doing that. PHP is big. Yeah.
I just learned on Tuesday that a third of the jobs running on their supercomputer.
Yeah. Well, yeah, I've heard this. Fortran and COBOL are still out there. I've started programming in Fortran long ago in the dark ages. If they finally fire me around here, maybe I'll go back to doing that. Anyway, yeah. No, must just be because they have legacy code, I would think. Because it's fast. They're writing new stuff in Fortran? Well, that's news to me. Okay. You know, when they first hired me here about 20 years ago, they would just cancel the Fortran classes. They said, we don't need to teach this junk anymore. Nobody wants that. Maybe they'll have to bring them back. COBOL, COBOL, Snowball, and there's a bunch of others that are hopefully long gone. Lisp, holy Christ, I hope Lisp is gone. Yeah, well, nobody ever accused Lisp of being fast, but Fortran was fast. Sure, it ran on really primitive hardware. Anyway, but it makes horrible spaghetti code. It makes you want to cry. I spent years maintaining Fortran code, and holy cow, I was glad to have C. Anyway, so you make a thing on a server. Perl just has this syntax, looks pretty simple, like Python, and you can take data up to the server. There's an example here. This one had a simple cross-site scripting vulnerability. One of the first students that hacked me hacked that for him. If you hack any of my stuff, it's worth extra credit. Free, have at it. Anyway, so ASP is Microsoft's server-side language, runs on IIS, and active server pages. This is one of the many horrible things about the web. You had HTML, which has these tags like font and body, and then you put other languages inside the same file. Now, this is unsanitary and horrible, but it has become the traditional way to do everything, is to put a second language inside the same file. So this is HTML font, and this % stuff is not HTML, so the HTML parser ignores it, but another parser makes a second pass through the same file looking for other things. In this case, an ASP parser looks for those and says, oh, that's the ASP, I'll execute that code. As you can imagine, this leads to god-awful security problems when you put in something that confuses them about which language parser should interpret it. But anyway, when it does work, the ASP active server code is used to fill in things that were not there in the HTML. And so here, you make this stuff, and this says put time there, and it puts the time there so the person at the other end sees the clock there. They don't see the ASP code. The ASP code is filled in at the server as dynamic components. And this is how you get to the world of like content generation. Like if you look at an Amazon page, you don't all see the same Amazon page. You each see a customized page to match your situation and whatever you appear to be interested in. And this is the kind of thing you do. You don't just have one file and you're all looking at the same file. You have a file with dynamic parts that are filled in differently based on the time of day, your geographical location, the cookies they can find on your machine to determine what your interests are. And this makes the web much more valuable because you see ads that are customized to you, and so they're worth more to the advertiser. You know, this is the way it goes. You don't let everybody see the same thing. That's why we've moved ahead to having printed magazines where you mail out 100 million Sears Roebuck catalogs and they're all exactly identical to everybody. The web doesn't work that way because it's more efficient to customize everything. Yeah.
So one of the things I noticed in this section.
Yeah.
The Windows operating system section was full of fixes.
Yeah.
One ran after the other. I didn't see that so much.
Oh, no. Oh, no, not at all. It's far more complicated. And in fact, this is a real fundamental question you're raising. Why doesn't this stuff get fixed? There's a fundamental reason. The Windows is one product. If it doesn't work, there is one company, Microsoft, that is responsible, and they really fix it. The web is just like 20 different things running on different servers. So for example, SQL injection, which we're going to exploit. There's a SQL server handing out data in response to SQL queries. There's a PHP page taking data from the user and deciding what to do based on it. Both of those languages are maintained by different people. They're on different boxes. So each one of them fixes their product to where it works up to their idea of what it should do. And it's a disaster, and everybody can steal all the money, but it's nobody's fault. The PHP is working correctly. There's no bug to fix. And the SQL is working correctly. There's no bug to fix. Nobody owns it. That's what happens here. Each product works in isolation, but the whole system is a mess. And that is a big problem. And that is currently a somewhat unsolved problem. That's part of why there's a very strange thing in this business, which is that we are fantastic failures as security engineers. People get hacked more every year. There were 10 billion records stored in the last 6 months of 2017, more than one per person on the planet. we're obviously monstrous failures. We should all just be fired. Instead, they hire more and more and more of us because it's the same thing. You have a crime wave, you get more cops, even when they're not very good. What can you do? You get more cops. It's your only move. And this is one of the many reasons why this happens. There's a problem with responsibility and authority and unity on the web. You have experts on every server that say, my server is working fine, it's somebody else's problem. They're saying, my thing is working fine, it's somebody else's problem. And the people whose problem it is are the managers at the top who are not technical and don't know how to fix it. And it's difficult to get people ready to actually fix the system problems, which require a whole rethinking of how your business works. And this is how you move into DevOps and DevSecOps. You need people to stop thinking about just a small piece of the job, and you need everybody to think about the whole goal of our company. Are we actually producing our product and satisfying our customers? And everybody has to really be contributing to that, not just making your little piece work so you can go home and the rest is somebody else's problem. That's where we need to go, and that requires a whole different mindset. And we're getting there, and a few companies are getting there fast, like Amazon, and a lot of companies are still in the old model that totally fails. This is closely related to the primary problem of DevOps, which is you have a bunch of people that are like in sales and marketing that aren't technical, and you have one IT department that doesn't even know what you're doing. And you ask them to do all the technical stuff, and you wait for them to do it. And then when they do it, it's not right because they don't understand your product line, and they're too slow and incompetent. So the non-technical people start making their own Amazon servers and making their own stuff, which these people don't even know about. And that's where you have madness. And that's the problem you fix with DevOps. Everybody should know enough coding and enough technology to set up a server correctly. And they should be not expecting some IT department to do all the work, but now there should be like a quality control department that really does make sure that everything is right up to specs, and everybody has to cooperate, and they all have to be completely synchronized using the same version of everything throughout the whole company so that the quality team can actually check your work. And it requires a whole lot more work organizing your company, but when you're done, it actually works better. But this is not how companies usually happen. You have people, you hire more people, you hire another team, you sort of patch together these teams that don't really understand each other and try to get the job done. Anyway, this is a very good question. So anyway, like I said, Apache is the main web server you see out there. It's used by the small businesses. You can run it on any operating system, but it's almost always on Linux. If you're using Windows, you would now really use IIS. And you can write the scripting languages in any of a variety of languages. PHP is extremely popular. That's what WordPress uses. It's also extremely dangerous. Almost everybody running PHP sites get hacked pretty fast, although WordPress is more secure than it was in the past. And like most open source products, PHP has a name that is a joke. It stands for PHP Hypertext Processor. It used to stand for Personal Homepage. They decided to be even cooler to make the P stand for nothing, which is a cool joke if you're into this stuff. So PHP stands for PHP Hypertext Processor. This is hilarious if it's late enough at night and you drink enough caffeinated beverages. Anyway, so now you put this stuff in your web page with less than $PHP instead of % like ASP, and now you can put PHP code inside an HTML file like everybody does, which is, by the way, a terrible idea, but it's what we all do now. It's the tradition. So it looks like this. You have a web page with a title, and then you have PHP code in the middle, and then stuff here. So your web browser only renders the HTML, and the server takes the PHP and puts some code in there before it goes to your web browser. And Cold Fusion is another product now owned by Adobe, and it uses these CF tags. It costs a lot of money, so I've never used it, but there's the CF location and all that. Again, they're not HTML tags. They're special tags which your HTML parser will ignore, and the Cold Fusion parser will find them and feed in data. And all of these have a long series of vulnerabilities, and each individual product patches their vulnerabilities, which we see here, but that does not really patch the whole system that any company uses, and therein lies the huge problem of security on the web. VBScript was Microsoft's attempt to get in here, Visual Basic, and they have their script type, text equals VBScript here, that you can put text in that do things. Again, active scripting inside HTML code. And it, of course, has its series of vulnerabilities getting patched. And JavaScript is one of the big ones. JavaScript and PHP are the open source big ones, especially now. With Node.js and Angular, JavaScript has really jumped up to be the king of almost everything on the web because of a decision by Firefox and Chrome to rewrite the JavaScript interpreter and make it 100 times faster about 8 years ago. And they left Internet Explorer in the dust, and they created a whole new generation of active content that will only run in what they call the advanced browsers. So Microsoft was finally pressured to join the crowd and improve their JavaScript processor, and now almost everything is done with JavaScript on the web, and everything looks a lot prettier as a result. So JavaScript has these functions like alert. You just have script type equals text JavaScript, or you can just not even say what the type is, and it will assume JavaScript, which is usually what it is, and now you can put active code on the page. This thing pops up an alert box when you click a button. And so JavaScript has its vulnerabilities too, like everything else. And so here's a link from a few years ago, populated languages. Java is big, C and C++ and C# and Python, but JavaScript is there and it goes up, and PHP, you know, and then you got this crazy stuff like R, and now there's Go that wasn't even on this list. Like I say, everybody has to write a new language constantly just to make us all crazy. But anyway, this is from a few years ago, but I know the headers are still up there. Java is huge, JavaScript is huge, C and Python are huge. Those aren't going anywhere. Python is very popular. These go they go back and forth like any horse race, just like, but they're all, the top 10 are always pretty much the top 10, although I think Go has now muscled its way up there. But I mean, that's why you're good to learn one. You should all learn at least one programming language. You're nowhere in this business if you can do no coding at all. If you don't know any coding language, I would recommend Python. It is the easiest to learn, the easiest to do simple things in, and you're not, you can do a lot. So if you only know one, learn Python. If you want to learn more things like Java and C and Go, they're all good too. Anyway, I guess we made it up to some cahoots so we can stay more or less on track here. Well, I thought that stuff, I don't want to go through that stuff in great detail because I want to get to SQL injection, which is really important. And I'll demonstrate that. And I've had some students saying they're having trouble with the SQL injection project, so I really want to make sure and give you a good demo of that. So this is chapter 10 in 123, which ought to be in my favorites. And it is, maybe not. How are my favorites? That would explain why I'm not finding it. Okay, favorites, there we are, chapter 10, 10A, that would be good. Okay. And there should be noise. Where's the noise? There's the noise, okay. There they go. Good, while that's happening, I'll bring up the file to record the winners.
You're looking at getting into network security or pen testing down the line. It would be incredibly useful to also Python.
I would just do Python. That's the first thing. Don't do any other language until you know Python, and see how you like it. But, if you like coding, learning other language is fine. But if you don't, then make sure you at least know Python. But certainly, the more you know, the better, of course, in every way. But there really is a different staff coding, and doing the security review is a different issue. Yes, you need to know some assembly for malware analysis, and you typically need to learn some C to understand assembly. But you don't need to know enough to be a developer in C to understand assembly. All you do is you learn how to use certain snippets where the security flaws are. But you should know how to actually write something in Python that works, because you're going to need to script repetitive activities. You're going to be doing something and you're going to say, I need to do this 100 times, and then you're going to wish you knew some coding. And for problems like that, Python is the answer. If you're doing Windows system administration, you must learn PowerShell. Nothing else will do, because it's specifically designed to do things like push out an update to all 10,000 machines and all that jazz. That's what you must use. Yeah.
So, employment specialist.
Yeah.
But Windows administration jobs have $20,000.
I'm not surprised. Microsoft. Yeah.
Which there are the greatest number of openings for the least number of people.
Yeah, Windows Server is very good to learn. Like I said, Microsoft has record profits. Domain controllers are everywhere, and it's hard to find people that can run them. So get your Microsoft certs if you want to be a server administrator. That's very valuable. Anyway, I guess I'll wait a few more seconds, see if we got any more customers. Apparently not. Okay. So, Microsoft's web server. By the way, Microsoft, not to be left behind, has also made their acronym different. This used to stand for Internet Information Service, but now Microsoft has announced that the name is just IIS, doesn't stand for anything, because they don't want to be like, inferior to PHP or anything. So you can always count on Microsoft to jump on anything 10 years too late with only half of what it should be. But they still make record profits. What's that? Apparently it just is, yes. All right. What is the most popular web server? This question changes every few years, but I know the current answer. Also IIS now. It used to be Apache, but IIS picked up in the last 2 years. IIS is now the most popular. I actually taught this one of these classes at Microsoft, the iClickers in the old days, and I had the Microsoft employees getting what the least secure Microsoft product was, and they were picking the wrong one that wasn't even a Microsoft product. They were pretty embarrassed too. Anyway, so and asking what the most dangerous product is another thing where it changes every year. For a long time it was Java, then it was Adobe Flash, then it was Microsoft Office before that. I don't know what it would be these days. Anyway, so which one of these is not a programming language? Talked about this in the previous class. HTML is not programming, it is markup. You cannot add numbers or anything in HTML. That's why you have to add all this other junk like PHP or Cold Fusion or something to put in the programming in there. So what language uses the question mark? PHP, very easy to use. I use it all the time. Also very easy to get in trouble. All right. What's the most popular programming language? Oh, boy, this one changes every few years, and I don't know. Well, I guess I know what my picture said. I think in that list, Java's what the picture said. Let's just take a quick look here and see what to see. Most popular. Let's see if anything else has changed. I see it changes all the time. I think Java always stays way up there because even though Java is pretty miserable stuff, it frees you from customizing your code for different operating systems. It runs equally terribly in every OS. So
universally, when we search for what's popular, there's a lot.
Yeah.
Python,
Oh, yeah.
JavaScript, Java.
Yeah. Let's see. Number one, JavaScript. This guy says, wait, JavaScript, what is this garbage? That must just be webs. What is this garbage I'm looking at? Where's Java? You can't. Am I supposed to believe that? I don't believe that. Let's.
I've seen them go back and forth.
Yeah, see, I think it depends on how you measure it. If you take visitors to your site or people in one area or something, that's why it's hard to say. But this guy also puts JavaScript at the top, and then Python, C, JavaScript, Java. Well, it's up there. Anyway, I'm not sure exactly I graded this right. That's a hard question. You could argue maybe I shouldn't grade it because it depends. Anyway, I'll take these as the winners despite the defect in the system. Let's take a 10-minute break. We'll pick up at 7:15 because there's more to do here. I see a comment coming in. Let me see what they're saying. Oh, many comments. Does ASLR slow down code execution? That is a very interesting question. I do not know that. We'll see. Coinbase has absurd exchange rates. Yeah. Characteristics of malicious malware JavaScript. Well, the most common JavaScript malware I know of is Monero miners. You put JavaScript on a website and anybody that views your web page is now mining and putting money in your account. That is really common these days. People say it's like the #1 attack they're most afraid of. Yeah, Monero wrote this code. See, the idea is instead of having a paywall, you could put a cryptocurrency miner on your page and then anybody that views it is paying money. And you can even have them agree to that and everything. But what people do is put it on pages without consent. So your CPU goes to 100% and you're making money. That's the main use of it. And Monero is the code that somehow can be mined and make money even with just JavaScript in a browser. So that is the most common thing people do with malicious JavaScript. Anyway, I see a name. Go ahead.
Are you running on Hopkins or are you
Running what?
what
Oh, I have no idea. Not the latest one.
Then you
What's that? Oh, well, you can just tell me. I'll stop the recording, and the share is still on, but I'm going to pause the recording. And let's carry on with the slides, and then we'll be in SQL injection quite soon. So, all right. So, you have this is a very simplified example of a modern network. If you take the web application hacking class, which I think we'll have again next semester, we go through this in more detail. Real networks like what we're working on CCDC have about 10 servers or more. But at the very least, you'd have a client down here signing into an account. They're sending their name and password up with HTTP to a CGI script. That takes the name and password and then passes it over a network to a database server to compare to like a hash value stored somewhere, and then it decides whether to let you in or not. So you have a PHP or Perl script running on the web server, and then you have a database over there, and it has to send network traffic to do that, and it uses one of these ways of packaging up the traffic. ODBC is the old way, open database connectivity, and there's newer techniques. They all do the same thing. They're just a way to move a request over a network over to a database server, so it can hand up the data that's stored in there. And so there's different technologies. ODBC was the original one, the old-fashioned one that works on almost every product. It's the open format. And this can go to Oracle or SQL or a whole lot of others. And it's just the standard way to move things over a network. There are other ones, OLADB, object linking and embedding, and ActiveX data object, or Microsoft's later versions of ways to do this. Microsoft's universal data access, but they all accomplish the same job of just somehow packaging up a question like, what is the password? Is this the correct password for the username John? You ask a question like that at a database server and it will then answer. That's all these are, is ways to pass a query over that to another server. Now, the problem is you've got application vulnerabilities here. If somebody can take over the web server, they can deface the website, steal the data, make new user accounts, elevate their user account to administrator, get into other people's accounts and steal their money. And this, of course, happens all the bloody time. So OWASP is a nonprofit organization with members from every company. Everyone joins OWASP and they all contribute to secure web applications. This is specifically for web applications. It is really big. Everybody loves it. My students and I were the OWASP representatives of RSA, and they told us to recruit new members, but we couldn't because everybody was already a member. Everybody just came by to say, I love OWASP. These are the greatest guys in the world. And I set up their training product at that time on some old netbooks, and we showed people how to practice hacking into web applications. And we had a great time, but the guy that paid for the booth got mad at us for not wearing suits. But anyway, that's RSA for you. But anyway, so one of the many things OAuth does is they publish the top 10 application security risks. And the number one has always been the number one is SQL injection or other kinds of injection. This turns out to be an enormous problem on the web, and I have a whole bunch of projects where you use this. This is where you get to inject high-level code. You don't have to go in the binary. You actually can pass commands to the server inside something like a username or a password that was not supposed to have code in it. This sounds insane, and it really happens. And when it happens, it makes it very easy to hack the server, and that's the biggest problem on the web. The most important kind of this is SQL injection. It was developed 18 years ago, I think, by Rainforest Puppy, and at that time, 11% of the web is vulnerable, and we spent the last decade or more training everyone about this and educating people, and as a result, now only 11% of the web is vulnerable. We're getting nowhere because every time we patch a server, another generation of students graduate and put up another server with the same problem, because all the textbooks and final exam and training courses all teach you to do it wrong. It is a very strange place we live in. They teach coders to write crap, and then they hire us to patch the crap, and then they have another generation and teach them to write the same crap again. And then they hire more of us to fix the same crap again. It's a mighty strange world we live in, but it's job security for us. Anyway, so then there's a lot of other ones. Broken forms of authentication, where you log in, but it doesn't really keep track of who you are properly. Exposing your sensitive data, various other ones like broken access control, where you have, for example, routers, typically home routers. You log in as administrator, then you get to a page, but there are no actual sessions or permissions. So if you just put that page in your bookmarks and come back tomorrow and go there without logging in, you get in, because they didn't actually remember who you are. They just thought you wouldn't find that page unless you went through the login screen. It's just like, there's things a lot of people do that's basically security theater. They make it, this is what encrypted USB sticks were. Encrypted USB sticks came out about 8 years ago. And at that time, almost all of them were not actually encrypted. All they did was pop up a login box when you plugged them in. but they weren't really encrypted. If you just imaged them with a forensic tool, the data was on there. But you couldn't just get the data by plugging it in and opening the folder without putting the password. That's what they called. It was therefore a little more secure than the unsecured stick, but it was not actually encrypted on the stick, except for Iron Key, which cost more. That was really encrypted. Anyway, there's security misconfiguration. And one of the big ones down here is A9, using components with known vulnerabilities. This is what happened with Heartbleed and many others. An important cryptographic library had a security vulnerability, and everybody used it without knowing that. This is supply chain problems, and it's huge. When you make your products, you're using stuff that came from other people, and you're relying on them to not give you broken or poisoned stuff, and you really don't know if that happened. And this is why, even though it seems that a Bloomberg article accusing the Chinese devices of having chips in them is false, the actual problem is huge, that you're using stuff that came from some country you don't trust, made by people you don't know. How do you know they didn't poison it? How could you check it to make sure? That is actually very difficult. That's supply chain management, and it's a big problem. Anyway, so here's serialization. That's a big one. So if you want to move a bunch of data up to the server, you serialize it, some long string like this. So all these things, customer name and their contract ID and their password and everything is all stuck in some long blob of data, moved to the server as one object, and then parsed back into data. And as you might imagine, this is fraught with problems. It means if I could inject a special character in the name, I could confuse the parser into not understanding it correctly at the other end. And that's essentially what SQL injection does. And there's a whole series of serialization attacks where a special character is misinterpreted at the other end. There's an enormous number of things on the web where some server handles data, then packages it up and passes it on to another server which tries to interpret it. And this is like having instructions in Chinese that are then translated to German, that are then translated to English. Every stage you have a high chance of confusing the next device. And nobody will accept the problem. Each one will say it's somebody else's mistake. I processed it correctly. This is the problem. So cross-site scripting is one example of this. You put some script tags in your text, and it shows up here. So let me bring this one up. If you go to my demo page, AD, there we are. All right, there should be, here's some cross-site scripting demos in here. All right, so here is reflected cross-site scripting. So I have a message, developer was drunk, I submit, and it says developer was drunk. But I could put in this. Instead of putting in that message, I could add this code to it. And now it's going to print that, and when it prints it, it's going to pop up a box. Because part of my message, I could put this in my username, I could put it in my password, it's going to, something that plays on screen, you can put it in your search query. It now interpreted that as active code. So this is what the MySpace forum did. The most famous example is by Sandy Kamkar. He found out that he could put something on his MySpace wall that had code in it. So he made a post on his MySpace wall that would, anybody that saw his wall, any of his friends, would now add him to their friends list and put this code on their wall. So within like 1 hour, he had like 100 million friends because everybody was automatically added to his friends list as soon as they viewed his page. And that's, this happens a lot. Like I say, Monero miners is a big one. I put JavaScript on somebody's page, and now everybody that views that page is mining and putting in my account. You can totally do that. You can do it with ad tracking. You know, anybody that views your page, this is why it's insane. Anybody that views your page is downloading code that you put up there and running it in their browser. This is like free opportunity to run code on other people's machines. If you can inject script, that's why if you let people post anything, like on auction sites where they can put up a picture of their product and a description of their product, if you don't carefully filter that code out of that, they can add code in addition to adding static content, and now it runs on every customer. That's what cross-site scripting typically is. People can put up something that runs, your customers can attack each other by bouncing the attack off your server. Companies, 80% of sites are vulnerable to cross-site scripting, and companies typically don't care because it doesn't put the company directly at risk. It doesn't let you hack into the company's server and steal their stuff. It just lets one customer attack another customer, bouncing it off you. And that's not exactly their problem. It's a sort of reputation issue, but they don't regard it as a high priority problem. It's also very difficult to fix because you have to filter the input from everybody in every form. And somewhere in your company, there's somebody that put up a page that doesn't know this. And it's so much bother to like track them down. Anyway, so that's the game. You can also steal people's authentication cookie. I can put up a script that'll run on your machine and steal your cookie and send it to me so I can now log in as you. Customers can use this to break into each other's accounts. But again, it's not exactly the company's problem. There was no malicious code running on their server. It's not necessarily their legal liability. So, you know, many things like this happen. This happened to Hillary Clinton and Barack Obama. When Hillary Clinton ran against Barack Obama, they both used PHPDB, which is a common open source bulletin board system, and it was vulnerable to cross-site scripting. So somebody went to Barack Obama's page and they posted a comment with a script tag that would redirect you to Hillary's page. So from then on, anybody who viewed Obama's page would have it load halfway and bang, go over to Hillary's page, which you can totally do. In fact, let me just do that one live because that's good, clean fun. I saw you did this here, so I can do that here. All you do is script document location. That should do it. By the way, whenever you're doing this kind of attack, always put it in a clipboard because you often have to try a few variations. So now I'm going to post that. When I post that, I thought it would go over there. I must have fouled it up. Oh, I'm missing quotes. And what I missed another thing wrong. Also, a slice instead of a dot. Yeah, a few things wrong right there. Let's try that, I guess. And then maybe I have an example down there I can copy if this fails. I'll put that in a clipboard. Yep, didn't work. Let's see, I should have some examples down here. I see a chat coming in, I'll take a look. Here's the on-click, window open. Yeah, these are the ones that steal the cookie. Anyway, I'm not gonna struggle with it, we got other fish to fry. Let's see what this comment is. The issue I'm having is something I'm getting, what is this stuff? Died from EOF. Well, I have no idea what that is. I'll take a look at that later. All right, anyway, all right. I try to get that out of the screen. So anyway, so that's cross-site scripting. All right, so you have to consider the web server, what data goes up, what database server is used, and so on. If you have a static web page, then it doesn't mean it's completely safe. You might have directory traversal, although that's a pretty old attack, where you can just traverse to other pages. Most modern web servers will not let you do this because they do have permissions, and the web server identity is only allowed to access public filters. But there was a time, like in public folders. In the old days, like IIS, the really early versions, you could totally traverse over and execute system commands, like CMD. So you could just go in the URL of the browser and put in // Windows System 32 CMD and get a command prompt right in the browser and execute commands on the server. It was hilariously easy to hack Microsoft web servers, and that started the tradition of Linux being secure and Windows being junk, because it really was for a while, because Microsoft stuff was just really weak. Anyway, SQL injection is a huge issue. And so here's the point. SQL, you need to learn a little bit of structured query language. This is structured query language. So if you want to get information about a username, this will select stars, all the data from this table named customer, where username is name and password is PW. So that will, if someone has a name and a password of PW, it will return information about them. This is what you might do when you're logging in, and then it'll show you your profile. If you put in a name with an apostrophe in it, the apostrophe is a special character. And so when the name has an apostrophe in it, it causes the SQL server to misunderstand this statement. It takes the apostrophe the developer put there and pairs it with the apostrophe the attacker put there. So this is username equals empty field, or 1 equals 1. And this dash starts a comment line, so it ignores the rest of this. So now instead of checking to see your username is name and your password is PW, it just checks that username is empty or 1 equals 1, and that is always true. So now I passed whatever this test was. So typically the result is you log in as the first user in a database, which is typically the administrator, without knowing the name of the password. Yeah.
So when is it even 1 equals?
Because this apostrophe matches, so I'm checking for a username that is blank, which probably never happens, so that would always be false. But or 1 equals 1, this could be true or that would be true, and this is always true. So now I've made a condition that is always true. That's why you typically have, that's why you have the or 1 equals 1. By the way, this is one way to do it, where you have to figure out what the comment tag is. Another way to do it is to do it with let me just bring up my SQL injection demo live. You'll be doing this in the projects if you haven't already. If I go here, here's the SQL injection one. Okay, so This is a database I got from Spider Labs. All right, so this database has two tables in it, users and SSN. And this has two fields, username as admin, a numeric field, and this has a name, two text fields, name and SSN. And so here's a select query, select star from LOS from users. That'll give me everything from the user's database, which is fine. And I could now put in conditions. Like I could select everything from the SSN table where the username equals Herp Derper. And now that's the condition. Where that condition is true, I'll get the data. But if the name had an apostrophe in it, like O'Neill, now it will misunderstand this because it interprets it as name equals O, and then the Neil is supposed to be a command. So now part of the name is interpreted by the SQL server as a command, but Neil is not a valid command, so it gives me an error. When you see a syntax error, that means you have the kiss of death, the fatal flaw, because that means I'm able to put in data which causes it to become an invalid statement, and that should not be possible. I'm logging in. I should only be able to give you a name, and the name should either be accepted or denied, but there should be no name that breaks the syntax of the line. If there is such a situation, then I'm actually able to inject active code, not just passive data. And that's what happens in all command injection. It's very wonderful for attackers because they're just asking for it. So you can now write to a file. This is a valid SQL command. I can write literal text in out file. You just can't change a file. So I'm going to make 122. Now I'm going to write an attempt test 122. And when it runs, there are no results, but there's no error message, so it worked. So to see that file, I have to go up here to my server, and then I have to go to temp test 122. So it will be, get rid of all this junk and put in temp test 122.htm, I think. Yep, and there it is, literal text. So I can now write a file on my server with the select command. So that's how you write to a file. Here's how you read from a file. You revert to a file, it'll print the results. But the problem is nobody in their right mind would ever let you type in a select command on the server. That's far too much power. Nobody gives you that, and you wouldn't want it anyway. What they give you is a login field where you just put in your name and password. And then on the back end, it runs a select command that the developer put there. So I'm able to put in Herp Derper, but what it's actually going to run is this command, select username from users where username like name. The only thing I can do is put stuff inside there. The rest was written by the developer and I can't change it. So normally this is okay. Herp Derper will show me the result of Herp Derper, but the problem of course is if I have an apostrophe here, then I'll get the syntax error because the apostrophe the developer put there matches the apostrophe I put there, and now this is supposed to be a command. So I can, this is what always happens in exploit development. You put in garbage and you get a crash. That's a denial of service attack. I can now make it have an error. But if I want to take control of the server, I have to put in a more carefully crafted attack that does not cause an error, but causes an unexpected result under my control. Yeah. Yes, exactly. And it herps the name, and now derper is supposed to be another command like where or. So now part of what I put in that should have been text is interpreted as active commands. Because I'm able to insert this special character, and at the other end it tries to match special characters. This is a fundamentally very stupid situation where what I took was put in a line of text, passed to another server with no context, that then had to try to figure out how to parse that text. This is what happens when you have completely independent servers that don't really pass enough data from one to the next. It gives it another line of input, which it has to reinterpret. But this is the way it typically is because web services are a bunch of independent services patched together with little lines of code moving one to the other that don't really give it enough information to know exactly what you wanted it to do. So here's an example. This is the, so what you do, I can now target any database on the server, but the only, people can name the database anything they want. They can name the tables anything they want. Now they often choose common predictable names like customer and account and product, but what I can do, rather than guessing those common names, is I can use the database names and the and table names that are automatically created by the software. Databases manage their internal structure with the database itself. And so a SQL Server database always creates this thing called table schema. From information schema tables, that's how it keeps track of what tables exist. So this command will target the automatically created thing that always has the same name. So let me run it and then we'll talk about it. This works and it gives me a list of all the databases on the server. And the reason it works is because I gave it a username of that whole mess. But what it interpreted it as was like this, and then the rest of it was active command. So it did the first query where username like nothing. There will be no results from that query. Then union, another select query. You can take one select query and add a second select query to it, and they'll take all the fields it found from the first one and add it to all the fields it found from the second one. So on the second one was totally under my control, and that is table schema as username from information schema tables where A equals A. And notice, instead of trying to guess the comment command, I gave it this stuff where I put in 1 apostrophe at the start, and then I put in 3 apostrophes at the end. This is a very good way. I've used this on a lot of SQL injection and hacking contests. This is much better than trying to guess the comment character. It turns out that it's hard to find the right comment character. This way, I don't have a comment character. Instead of saying where 1 equals 1, I said A equals A, missing the apostrophe. So the apostrophe the developer put there will match this, and this condition is always true. This is a very good way to use up the extra apostrophe that would break the syntax. So now I'm able to get the names of all the databases on the server. And there's one named SQLOL. That's the one I'm going to target. So after I know the name of the database, I want to find the tables in that database. And you do that with this one as a username. And so now I fed in a username that goes all the way down to there. And the apostrophes the developer put around the username create a valid command, but it does not mean what the developer thought it was going to mean. And instead of looking for a name that is all that garbage, it looks for a name that is empty, and then it looks for table names from information schema tables where the table schema is SQLOL. So these are the names of the tables in that database, SSN and users. So now I know the database name and I know the table name. Now I can find the field names with a third query in the same regard, which is this one. This will be the columns or the field names. And again, I don't need to know the name of anything to start with. I was able to start with the system generated fields. So again, I fed it this long mess of the name, but the server misunderstood it as 2 queries, one with nothing in here and the other giving column names from the table. So now I know the columns are name and SSN. And this is the steps you can go to zero in on what you need, even when you don't have any data, any information to start from.
So the username after the ask, is that a fixed thing or is that
Username after what?
the ask?
After the at.
Before the from?
Over here?
No, one line.
This thing here? That came from me. I typed that in. But I did it. I chose to code column name as username so it would add to a table named username.
So the username can be anything you make up.
Well, this part here was put by the developer. I can't change that. I can only change this part here. But I can guess what happened here when it says usernames found. I know they're calling this username. So when I find a new thing, I should call it username to make it add. That's optional, by the way. You don't really need this username. It's a good practice, but you don't always need it. SQL will actually let you have one text column and another text column with a different name, add. It will complain, though, if you have a text column and you try to put numbers in it. Yeah?
Sorry, simple question. How common is this?
11% of all the websites are vulnerable to this. 11%. Yeah. Yeah.
So from this injection, now that you know those 2 columns,
Yes.
are those columns or tables?
Those are columns. The table is SSN and the database is SQLOL. So now I know everything. I know the name of the database, the name of the table, and the name of the columns. So now that I need all 3 of those things, now I can do the final thing here, which gives me all their secrets. That's why this is so fatal. This is how they broke into many databases. If you have this flaw, people can usually steal the entire database off your server without even knowing any coding, without even uploading malware or anything, just by using your web page the way it is just sitting there. And here I get all the data. names and social security numbers off the server. In order to do that, I needed to know the name of the database, the name of the table, and the names of the columns. That's why I needed to do the 3 previous steps to get here. But it's pretty mechanical, the 3 previous steps. It's pretty much repetitive. And this is how they stole many, many databases. I think something like 98% of all stolen data has been stolen from this attack. Although that statistic is about 4 years old, because I think it's no longer true. I think now it is open Amazon buckets, which are even worse. Because people go to the cloud, they image their database servers, they put it on Amazon, and until I think 3 months ago, by default, Amazon made every bucket wide open to the whole world. You were supposed to know to put a password on it, and they don't make it obvious. So an enormous number of people put stuff up there, and the whole world could see it, and they didn't know that. And people would just find their entire database just blowing in the breeze over and over and over. So that's even worse. And Amazon finally got convinced to change their policies, so it forces you to put a password on that stuff or something. Mongo is another one. Mongo is a database, incredibly popular. People will hire you if you can do Mongo at all. They're using it like mad. It's apparently wonderful, but it warns you in the documents. Mongo is totally insecure. There's no password at all. Don't connect it to the internet. And thousands of people connected it to the internet. And everybody can just go right in and steal your stuff. Yeah. Okay, but anyway, before Mongo and Amazon buckets, there was SQL injection that just meant everybody could just steal your stuff, and it happened all the time. And it's still happening. It's just other things have become even worse. Anyway, all right. And this looks like okay, so let's go here. I'd like to make that big. There we go. All right, so we've been here. And so anyway, you should look to see if you can enter text with punctuation marks. This is the most common kind of SQL injection. If you get a syntax error, that means you've got a huge nightmare flaw. You should never be able to break the syntax of anything. Your user should just be able to hammer the keyboard like a monkey, and it shouldn't break the application. It should just say invalid name or something. It shouldn't say, you changed the syntax, you're executing strange code on my server. That should not be an option. Anyway, so typically you have another server holding the credentials to authenticate people, and this is often a mistake too. You have to somehow send data to that server, and you have to consider how it's transmitted and how it's stored at the other end. Many people fail to store it securely, or they fail to transmit it securely. So the typical general platforms are either an open source shop, and so you use Linux, Apache, MySQL, and PHP, which is called LAMP, or you're a Microsoft shop, and then you use IIS, ASP, and Microsoft SQL Server. Usually you do one of those two things, unless you're really rich and use Oracle. Those are the most common things you will see. So you can tell these very easily by just running Nmap or anything against the server. It'll either be all Microsoft stuff or it'll be all open source stuff in most cases. So people find SQL injection like crazy. You can just write a little Python script. You can download a bone scanner. People find thousands of them, and they just dump them on Pastebin. You can just go on Pastebin. There'll be like 10,000 SQL injection vulnerable sites. I spent some time in other classes notifying these people. The Supreme Court of Britain was vulnerable to SQL injection. And the woman, the administrator, contacted me and said, I saw myself on that list. My heart stopped. Oh my God. Say, you totally are. You know, sometimes people even fix it and say thank you. Mostly they just threaten you and try to prosecute you and stuff. This is called white hatting, warning people about vulnerabilities. It's considered wholly unprofessional and a form of self-abuse. I've done a lot of it, but it's pretty unjustifiable. All the pros say, if you find a vulnerability on somebody's website, the professional thing to do is say nothing and let them get hacked. That really is the best move if you can stand it. Anyway, but you'll find them all over the place. There's Sheraton resorts and everywhere. There's an incredible number of people are vulnerable to SQL injection on the web, and you can try telling them, good luck. I did hundreds of them in my study. My conclusion was that 2% of them will fix the problem. And if they hadn't figured it out for themselves, they're too stupid to understand what you're saying. And they will typically accuse you of being some kind of criminal for talking to them about this scary stuff. Anyway, they're all over the place. Here's one. So I went to this Vortex comment, and here it is. You have an error in your SQL syntax because I put an apostrophe at the end of the URL. On you go. Here, and you can, here's another one. Burke Suite Workshop, yeah, Acme Laptop. Anyway, there's a lot of these out there. Here's one with local file inclusion. This is another one where this is what happens all the time in PHP. In PHP, you'll have a PHP and then a parameter that's the name of the file. And you can often replace the parameter with a path, so I can now see the password file. This is what you often do to test it, because the password file is world readable. There's no secrets in the password file, really. It's usernames, but the passwords aren't in here. They haven't been here since 1975. In 1975, they figured out it was a bad idea to put the passwords in here, and they just put an X here. The passwords are in another file called shadow, which is not world readable. But this shows that I can read things I shouldn't be able to read. You're only supposed to see things in the var www.html folder. I'm not supposed to be able to see system files, but if they don't enforce permissions correctly on the server, I can. Not this directly, typically. You have to elevate it to root first, and the word that's more protected. And so, if you want to do web application security testing, we have a whole class in the next semester. There's a ton of things they want you to do, and here's some of the stuff that OWASP recommends. Many, many things: fingerprint it, map out the application, test the methods for security, test the definitions of users and whether they have weak username policies and password policies and lockout mechanisms and the password reset system. There's just an amazing number of things that go wrong on the web. This is why everybody's so unsafe. It is not like just 3 things to test. There's like 100 things to test. That's why it's highly unreasonable to take your poor overworked developers that are trying to get whatever you're ready for next week's launch and tell them, oh, by the way, do all these 100 things that you don't even understand too. That's why you kind of got where we are. The web is just insanely complicated. Yeah. Yes, that's right. You have a security team doing this, and you have people, and the most important thing a security team has to do is make judgments of how much of this stuff is important enough to fix right away. There are 1,000 things wrong. You can't possibly fix 1,000 things. You can maybe fix 3. So figure out which 3 really matter. That's why you need somebody with experience to guide you. And there are many, many more things here: session fixation and cross-site request forgery. We'll cover a lot of these in 129S. There's cross-site scripting and SQL injection and a bunch of others. There's just an amazing number of things going on in a web server, and every single part of it tends to have many, many flaws. So, you know, just thought I'd put that up there so you see the work. Yeah.
So, when somebody asked how many, what percentage of the
Yeah.
sites were open to attack, what percentage of like general attacks are from, you know?
Well, it's the most common attack of all is attacking web applications. And SQL injection is really, I mean, 80% of them have cross-site scripting vulnerabilities. They say 11% of them have SQL injection. Probably some other percentage, probably smaller, have local file inclusion. There's just, it's where, as you know, not every site is vulnerable, but enough that every day there's another headline of somebody getting hacked. A lot of them. And those are simple. These are script kidding attacks. You just jack somebody through the browser. The more professional pen testers run a whole bunch of things. Here's real pen testers. A professional pen tester has a success rate of 100%. They always get domain administrator at every company. And when you patch everything, you hire them again next year and they get it again. There's no amount of money you can spend that will stop a professional pen tester or a government from getting in. All you can do is have other layers of defenses where you hopefully notice they're in and kick them out before they get the crown jewels. That's why it is we have done in the modern world of web application security, the big improvement is we have lowered our expectations. 8 years ago, you put up firewalls and stuff and say, we're going to keep the attackers out. Now we admit there's no way to keep the attacker out. The attackers are getting in, there's malware on the system, and we're going to somehow cope with the zero trust model where we can't even trust our own systems, and we're going to somehow protect our goodies anyway. That's where we're at. So this is like when you're fighting a battle and you break through the wall and you retreat to the keep and you fight them out of there and you retreat to like one locked room. That's what we're losing, but we're still fighting. That's where we're at. That's why they need so many of us, because we're so useless. So anyway, Nikto is, there are scanners to scan the web. Nikto is an old-fashioned one. The good thing about Nikto is it's really fast. By the way, Nessus is really fast. I added Nessus this semester. Nessus used to take forever, but now it's only like 5 minutes. But anyway, you can run Nikto and it will tell you, it will just test a certain number of common attacks and tell you if you have those vulnerabilities. Nessus is great. It's in your projects now in like 5 minutes. It's the most popular vuln scanner in the world. It will scan and tell you if you have any of a wide variety of problems. Neither of them is very thorough. You can have a ton of problems that they don't pick up, but they will pick up some things. And it'll give you a report rating them by critical, medium, low risk, and tell you what you got. And if you run it on like an old system, like my Windows 2008 server, it'll find a bunch of problems like it should, of course. That's 10 years out of date. There's a bunch of known problems in it. And W3AF is a free open source scanner that sometimes works, but it crashes and fails a lot. Nessus, I think, is a whole lot better. Skipfish is one Google put out. It's not all that good at finding vulnerabilities, but it's very good at finding every file because it came from Google Spider. And the main thing about Google is they want to find every file on the web. It's really good at finding every file. Anyway, I got a few cahoots about that. And then we'll be done with this, and I'll just go to the lab. Cahoots, this should be 10B. There they are. All right. Longer than usual today, but I really wanted to talk about those projects. Now, like I say, if you only learn one thing in security, it should be SQL injection. That one problem is the biggest problem in the world. Naughty nicknames, yeah. Every time I see this pop up, I wonder if they noticed something, but I think it's just generic. There was one of the malware attacks people had would pop up a box saying we've detected you surfing porn. And some guy was actually surfing kiddie porn, and it popped up and said the FBI's caught you, and he actually went and turned himself in. I went to prison. That's, people are guilty, you know, when you mess with them, some of them like have a bad conscience, have unexpected results, you know. You learn this when you teach here. It's like on the web, you can't put out jokes casual. I mean, somebody out there could really be super tense about something, and you end up having a explosion when you say what seems like a harmless comment. It happens a lot on the web and stuff. This is why people are mad at Trump, right? Because he's throwing around racism and stuff, and then somebody goes and shoots up a synagogue, and they say, you know, you're asking for trouble by constantly poking this dangerous space. The Supreme Court says free speech doesn't mean you can yell fire in a crowded theater, but that's kind of what politicians do, is say something to get everyone riled up. Anyway. Horrible name, that's right, horrible name. I'll give you a few more seconds. Oh, maybe I'll look at the chat comments, see if anything. What should I do about the exe files not working? Okay, I will take a look and see if I can figure out what is going on about that after this. I don't understand it, but let me see if I can figure it out. All right. Let's try this. And I'll look at those chats and see if I can figure out what's going on. So which one lets you see private files, like its password? Okay, that is local file inclusion, LFI. Very common problem with PHP. Which one lets you steal the contents of a database? Okay, that's SQL injection. Which one lets one website user attack the other users?
Upset of the week, baby. Who's gonna get him?
All right, that's cross-site scripting.
Yeah.
All right, and which is the vulnerability scanner that is not free?
How about that?
Nessus, the most popular one, has a free version and a pay version. All right, so let me record these winners, and then I'm going to attempt to figure out what's going on. Somebody says some exe does not work. So let me see if I can figure this out. This is BackX, okay. And then 3 for it's me, and let's tell me who that is. Okay, let me save what I got here. And let's see if I can figure out what these chat messages are about. Something is not working apparently. Died from EOF error. We download some file. Windows Firewall 15.3. Okay, let me see if I can figure out what's going on here. 15.3 has a file. come on, projects. 15 is firewall. And you make a bind shell. Okay, what is this 15.3 stuff? Reverse shell. Create a reverse shell malware on Corley and run it. Okay. And EOF, EOF, oh, 15.3, okay, thank you. So 15.3, good, you know something good. I don't know what's going on here at all. There.
Well, I got down from UFEO as well.
Oh, any idea? Okay, it doesn't, I don't have no idea what it is. So some file, okay, you create a file. I don't even see an exe file anymore. What is going on here? You set the rules. Where's this file? Corley reverse shell. I guess you're using a file from something previous. So it should have affected him back here. Here you got an exe. Is this what he's talking about that won't run? Shell reverse.exe? What is it to give you this error? I'm not understanding the problem here. What's that? 3 new chat messages. Okay, let me see if any of this will explain to me what's going on here. I download the exe files. I don't know which files. Let's see. Okay, this would be 15.1 and 15.2. Both exe files is the file you download from the Apache server. Some file doesn't run. Okay, let me find out what's going on here. Let me try this one and see if I can figure out what's happening. So there's a file somewhere. Where's the file? There it is. Okay, open this URL. Launching the bind shell, shell bind. Okay, let's see if I can run this. So here's a file. You have to put it in Internet Explorer. So let me try it. If I run server 2016, which is here. Okay, let's see what happens. It works on 2016. Oh, well, okay, then I guess I don't need to test that. So what is it doesn't work on? 2012? Boy, I don't know about that. Should work in 2012. Windows is Windows. Maybe it has to do with 64 or 32-bit. Now, when you created it, I thought it was, let's see how it was created. Here, this is what made it. And it should be a 32-bit binary, I think. That's what this will do. EOF error. I haven't seen this error. Somebody else saw it? Any idea what caused it? How to get rid of it? So you couldn't do this project either?
No, I had to look it up.
Oh, goodness. Well, if anybody can show me this, I don't think I have a 2012 machine. I don't know why it wouldn't run in 2012. Windows is Windows. I use the same EXEs to hack Windows all the time. I'm not familiar with any of these problems people are having. EOF. EOF, I would think, mean you're not getting a good download because you have a bad internet connection. You just have an empty file. Check the size of the file, because that just sounds like you don't have an internet connection. And when you do wget, you're getting an empty file. That's probably what it is, I would think.
The answer would be, I guess one of the last things you're supposed to do is cut off the connection to
Yeah, internet.
the internet.
So maybe they've done that and then not connected it again. I mean, because here's 2008, for example, and if it runs on 2008 and 2016, I don't understand how it could fail to run on 2012. Let's try 2008. But one thing, I'm most likely thinking if it's telling you an EOF error, that's making me think that it you just didn't get a download. You just have you can't ping Google or open a web page. So there's this thing, shell bind. Right, and you're going to have, it comes from, not my server, it comes from your server. So you're able to open a shell, but then what it is, it won't run.
I think the curve, that's a separate issue, but I am able to connect to the.
If you can run the bind shell.
Run it all. I think as far as the EXE, I think he was asking about, maybe that's the firewall. Or the defender not letting him open. Or like you said, maybe the version.
After blocking connections in the firewall, Well, I think, why don't you write something up with screenshots and email it to me so I can think about it, because I'm not comprehending the problem here. This, I think, is what happens when you make a vulnerability report. You always get, we can't reproduce it, we can't understand what you're saying. And here I am saying the same thing. The little bit of information I'm getting is not enough for me to have any clue what's happening here.
As far as would you reopen the firewall?
Yeah?
Re-enable it, and, which is supposed to cut off the connection between that.
Okay. An EOF error is after blocking connections. Well, why don't you take screenshots and email it to me, and I'll see if I can, and show me what you do and what you see. And if somebody will do that, then maybe I can find out what's happening. Apparently, a few people have a problem, and I need to look at it and reproduce it and understand what the problem is. All right.
When you enable the firewall, it's supposed to organically cut off the connection, but I have to technician supposed to press it up. Then only then does it cut off.
Okay, well, yeah, should I send this through Canvas? Through email is better. Canvas takes longer to get to me. If you just send it to, oh, that's right, you're not turning in homework this way. Just send it through Canvas. Sending it through Canvas is all right. I forgot I'm not using email to get homework anymore in this class. Sending it through Canvas is okay. If I somehow get it, then I can go through it step by step and find out what's happening. I want to know if something's wrong with the projects, but I'm not getting it from this. Anyway, I think I'm going to stop the recording here and go to the lab and see if I can help people. And if somebody shows me this in the lab, I might be able to figure out what's happening. But I need to see it go to find out what's going on here. All right. I'm going to end the meeting. All right.